core collection interfaces, general purpose implementations, more utility collections. Core collection interface, how many are there? 10. 10 completed. General purpose implementation, how many? Those 10 also completed. Next, more utility collections. Not done. More utility collections. First one, iterator interface. Second one, list iterator interface. Third one, map.entry. Here, entry is an inner interface of map interface. Next, scanner class. Next is class. Next, collections class. Comparator interface. Iterator interface, list iterator interface, map.entry, scanner, arrays, collections, comparator. Iterator interface, list iterator interface, map.entry, scanner class, arrays class, collections class, comparator interface. Is it over? Now, first one, iterator interface. First one, iterator interface. It is used to iterate elements of a collection. It is used to iterate elements of a collection. It is used to iterate elements of a collection. What is the need of iterating? What is the need of iterating? I'll explain. Is it over? Iterator interface, it is used to iterate elements of a collection. Why do we need iterating? I'll explain. For that, first one program I'll write. Suppose Here, any one collection, example, array list. AL equal to new array list. AL dot add. 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 System dot out dot println AL. Now, this is array list. Here, added elements are displayed. What is the output comes? Same order comes because array list insertion order is preserved. Our order maintained. Now, what is the need of iterating? I'll explain. So actually, further what will happen? One graphical user interface will be there. Graphical user interface. Roll number. So suppose hall ticket number. Hall ticket number. Name of the student. Marks of the student. So hall ticket number. Name of the student. Marks of the student. And submit button. Submit button. Data entry operator, you will enter hall ticket number, you will enter name, you will enter marks, you will click on submit button. Okay. This is going to be stored in database. Again, hall ticket number, name, marks, hall ticket number, name, marks, hall ticket number, name, marks, you will enter. The data entry completed. University announced result, they completed data entry. After that, later, university decided to add 5 bonus marks. Maybe some mistakes in an exam paper or something. Due to some reasons, they want to add 5 bonus marks. But data entry completed. Data entry operator, I completed entry. Later, they decided to add 5 bonus marks. Okay. It is entry completed. It is completed. It is completed. These all completed. Entry completed. After completing, if you want to add 5 bonus marks, suppose if I write plus 5, if I add, is it added to 83, 88 like that? No. Because what AL contains? Hash code. Hash code plus 5, if you write, error comes. Because you cannot perform any operation on hash code. See, if I run, error comes. Say Java C demo.java. If I compile, bad operand types for binary operator plus. First type is array list type. Second type is integer. Array list plus integer we cannot add. That error coming. That error coming here. Okay. Then what we, if you add manually, again 5 bonus marks if they add, again he has to enter data entry again. From the beginning, again he has to enter. That's what one graphical user interface will be there. Something bonus marks. Bonus marks. After that, submit. Here I'll enter 5. Then when I click submit, it should be added to all students. It should be added to all students. Then what we have to do is, from this collection, one element we have to iterate. Now, first 83. Extract this 83, add plus 5. Again, move the cursor to next. Add plus 5. Move the cursor to next. Add plus 5. Again, move the cursor to next. Add plus 5. Like that, we have to add. This button backside, we have to write that code. We have to extract, add, extract, add. that code we ought write. But if that program is there, what will happen? You'll type 5, you'll click submit. It will be added to all. That backside code only you have to write with iterator. How to iterate? See. This iterator will help you. How to iterate? You see. There are methods are there. Java P, java.util.iterator. Write this one. Methods. Node. It returns true and moves the cursor to next record. It returns true. It returns, sorry, 1 minute. It returns true if the next element is, it returns true if the element is present. Otherwise, it returns false. It returns true if the element is present. Otherwise, it returns false. This method, it returns current element and moves the cursor to next element. It returns current element and moves the cursor to next element. It removes the current element. Note on this all. As next remove. As next remove. Has next method returns true if the element is present. Otherwise, it returns false. Okay. As next method, it returns true if the element is present. Otherwise, it returns false. Next method returns current element and moves the cursor to next element. Okay. See, the concept I'll explain. Just you observe. Suppose like these elements are there. Like these elements are there. Okay. Like this you have elements. Cursor is here. Cursor is here. Okay. First, if I call has next, it returns true or false. See the description. It returns true if the element is present. Otherwise, it returns false. Okay. it returns true if the element is present. Otherwise, it returns false. Next method, it returns current element and moves the cursor to next element. Now, cursor is here. If I call has next, it returns true or false? True. If I call next method, what it returns? 34 return, cursor move to 92. Again has next. True. Next. 92 return. 92 return. Cursor move to next. Again next as next. True. 81 return. Cursor move to. Now again as next. True. Next. 54 return. Cursor move to next. Again as next. False. So until you get a false, you have to iterate. While iterating, here 34 comes no, 34 plus 5 you can print. Okay. Now has next, has next, you have to call again and again. After calling, here element comes. That is plus 5 you have to try. Okay. Now, these methods, instance methods or class methods? Instance method. Here abstract method, default method. This concept not completed. I have to explain. Interface contains default methods also. That is Java 8 feature. I have to explain. This after this topic, multi-threading, then new features. At the time we'll learn. Okay. Iterator interface. These methods, instance methods or class methods. Which reference required? Iterator. Which collection we are using? Then in an array list class, you have to search for iterator. No. Sorry. Again, iterator on Java p java dot util dot array list. In this class, methods. See here method, one method is there, iterator. This method, it returns iterator reference. With that, I can call. Write this one. It returns iterator reference. Method name is iterator. Return type is iterator. Is it over? Now, here, you observe after printing, say file, save. If I compile and execute Java C demo.java, Java demo, like this printed. Now, each and every element we have to iterate. So, cursor is here. Has next, true. Next, 83 comes plus 5. Again, moved. Again, has next, true. 48. Move the cursor. Like this, we have to do it. Now, for that, first of all, iterator reference required. For getting iterator reference, which method you have to call? Iterator. That method in which class? ArrayList. Here already ArrayList object is there. That object referred by AL. With this AL, can I call? Yes. What is the return type? What we have to write? Iterator. What we have to write? Integer. I equal to AL dot iterator. So it is a method in ArrayList class. This method return type iterator. With this I, you can call has next next. Has next return type Boolean. Until you get a false, you have to move the cursor. Until you get a false means outright while loop. While I dot has next. Okay. Now, here I dot has next true. It will enter. Again true. Enter. False means stop it. Now here next method we have to call. Here capital E. Capital E nothing but integer. Capital E nothing but integer. Then that method we have to call. What we have to write? Integer sum x equal to how to call? I dot next. System dot out dot println x plus 5. Can I write? Yes. In the place of integer, can I write int? Can I write? Yes. That concept is called auto unboxing. So it is valid. See, first of all, cursor will be 83 place. Has next true. It will enter. Next. 83 comes. Cursor move to here. 83 plus 5, 88 printed. Again as next true. Next 48 comes. 48 plus 5 printed. Cursor moved here. Again as next true. Next like this. Every element after getting this one as next false. File save. Compilation execution. See 83 plus 5 88. 48 plus 5 53. 81 plus 5 86. 19 like iterated. This is iterating. Not done. Program to demonstrate iterator. Program to demonstrate iterator.
Recording in progress.
True. While true, it will enter. Then next very
Recording
simple.
in progress.
That's what after getting enhanced for loop, these all not using. This is this is complicated, no? Now enhanced for loop, how to use see? Enhanced for loop. What we are tried for AL contains integer integer x colon AL over system dot out dot println. This is you can write int also auto unboxing. It is very simple. This is the reason only this is came. Say as compared to iterator interface, it is very simple. This is especially made for collections. See, now same output comes. See, this will later came. Starting it was not there. Now, program to iterate elements of an array list by using enhanced for loop. Ready, son? Program to iterate elements of an array list by using enhanced for loop. So it is very simple as compared to iterator interface. See, this is the purpose of enhanced for loop. Now, any collection reference you can write. That collection contains elements, no, that element type you have to write. Then automatically one comes, it is printed. In a more utility collections, first collection completed. Iterator. Okay. What is second one? List iterator. Not done. List iterator interface. It is also used to iterate. It is also used to iterate elements of a collection. It is also used to iterate elements of a collection. Already iterator is there. Why do we need list iterator? I'll explain. Nodal. Differences between iterator and list iterator. Differences between iterator and list iterator. Differences between iterator and list iterator. Differences between iterator, list iterator. Write two columns. Iterator. Next one, list iterator. Iterator, list iterator. First, iterator side. It is used to iterate. It is used to iterate elements of any collection. It is used to iterate elements of array list and linked list only. Iterator, list iterator, iterator side. It is used to iterate elements of any collection. List iterator. It is used to iterate elements of array list and linked list only. So list iterator only for list, array list and linked list only. It is used to iterate elements of any collection. But list iterator, it is used to iterate elements of array list and linked list. That is the reason name is list iterator, only for list. Next. It allows only forward direction to iterate elements. It allows both forward and backward directions to iterate elements. It allows both forward and backward directions to iterate elements. It allows both forward and backward directions to iterate elements. It allows only forward direction to iterate elements. It allows only remove operation while iterating elements. It allows only remove operation while iterating elements. It allows add, remove, and set operations. While iterating elements. So three differences. Iterator you can use for any collection. List iterator only for array list and linked list. That is first difference. Second difference, only forward direction. But here both forward, backward. Here only remove operation possible while iterating. Here one more element also you can add. Element also can be removed. Modifying also possible. So it allows only remove operation while iterating element. It allows add, remove, and set operations while iterating elements. That is, you can see. Here, you observe Java P java.util.list iterator. Here, has next, remove. This is, you'll understand further. For this one, lambda expression required. Java P java.util.list iterator. You observe here has next, has next forward direction. Here has previous, backward direction. But that type of methods are not there. No, no. Remove, set, add. Set nothing but modifying. Here remove only is there. It allows only remove operation while iterating. It allows adding new element also possible, removing also possible, modifying also possible. Three operations. This is the difference between iterator, list iterator. Okay. First one completed, second one completed. Same program. Here, what you can do? Here, previously you studied, no? No, this is you study, no? Here, what you have tried? List iterator. Here, method name, list iterator. Here, as next. If you want previous, as previous. That's it. Okay. So, iterator, list iterator completed. Next, map.entry. Map.entry. Here, entry is an inner interface of map interface. Here, entry is an inner interface of map interface. It is used to get the It is used to get the keys and values while iterating two-dimensional collections. It is used to get the keys and values while iterating two-dimensional collections. It is used to get the keys and values while iterating two-dimensional collections. So two-dimensional collection is different. Two-dimensional collection is somewhat different. How to iterate? See, it is used to get the keys and values while iterating two-dimensional collection. Now, methods. Write these two methods. Get key, get value. Get key if you call, you'll get a key. Get value if you call, value. How many two-dimensional collections you studied? How many two-dimensional collections you studied? How many? 3. Only 3. What are those? Hash map, linked hash map, tree map. Only maps are two-dimensional. Okay. Hash map, linked hash map, tree map. See, any one we can take. One hash map or linked hash map or tree map, any one you can use. For example, I'll go for tree map. Integer float tm equal to new tree map. Okay. Now, integer type keys, float type values. Suppose employee number, salary. Okay. Employee number, salary I want to maintain. Tree map dot add put method. Two-dimensional put method is 101 5000. Tree map dot put 102 6500. Tree map dot put 103. Tree map dot put 104. System dot out dot println tree map. Is it unordered map or ordered map or sorted map? Sorted map. Keys sorted or value sorted? Keys. While sorting, keys only considered. But I given directly sorting order only I given. That's what same output comes. Okay. Because I given 1 to 101, 102, 103, 104 only. Same order comes. This is, we got it. Now, here, for every employee, I want to add 500 bonus salary. Okay. Every employee, I want to add 500 bonus salary. In this case, what we are to do is, it is how it is stored, you observe. 101 equal to y 5000. Can you store in integer variable? No. Can you store in float variable? No. Can you store in string? Yes or no? Yes. But can you perform a 500 adding bonus? No. That's what map.entry. This one we can store in map.entry. We can extract key, we can extract value. Then value plus 500. That purpose map.entry concept. So that's what I given here. It is used to get the keys and values while iterating two-dimensional collections. This is actually iterating not possible. It is two-dimensional collection. What we have to do is, this two-dimensional collection, we have to convert into one-dimensional collection. Then possible. Again, iterator you have to apply. Then map.entry also you have to use. Then you have to perform 500 bonus. So iterating two-dimensional collections not so easy. See how to iterate. See how to iterate. You observe. Two-dimensional collection. Two-dimensional collection. Year, key, value. What I given first, 101 salary, 5000. Next, 102. What I given? 6500. 103. How much I given? 6000. Next, 104, 5500. This is tree map. Okay, this is tree map. This is, we have to convert into one dimensional. It is 0, 1, 2, 3. Here 101 equal to 5000. 102 equal to 6500. 103 equal to 6000. 104 equal to 5500. This is, will make it as set because duplicate should not allow. That's what set. Now, what we'll do here, what we'll do is, cursor is here. Cursor is here. Cursor is here. Okay. Cursor is here. Has next method I'll call. True. Next method I'll call. This is return. Then 101 equal to 5000. Get key method. Get value method I'll call. Here. Get key. Here. Get value. Here. Get key 101 comes. Get value 5000 comes. Cursor comes here. Again as next. True. Next. This one will extract. Map.entry will store get key, get value. Here now you can add 500 bonus. You can add, you can make like this, you can do it. So two-dimensional array collection, we have to convert into one-dimensional. Again, iterator you studied, no? Iterator. Then map.entry. Extract key separate, value separate, add 500 bonus. Write this one. So two-dimensional collection, we have to convert into one-dimensional collection. After that, we have to iterate with iterator. You will get a map.entry with that key value pair. So here key which type here? Integer type. Okay. This value which type here? Float type. Okay. This is map.entry type. This is map.entry type. That is map.entry object you have to store. Map.entry subclass, that object we have to store. So this is nothing but map.entry. Then only key. This is nothing but map.entry. That is nothing but map.entry type. So key equal to value. We are going to store. For that, this class, this interface design, this actually interface subclass, that internal, that part is hidden. That is only abstraction. So this is map.entry type. So this two-dimensional array, two-dimensional collection, we have to convert into one-dimensional collection. Then with iterator, you have to iterate. Then you have to store in map.entry. Then get key, get value. Then value separated, then find out bonus you can add. Otherwise, adding bonus is not possible. Say, this is as a one unit. Then how can you add? That's what you have to extract. Okay. Is it over? See. In this program, first tree map, java p java.util.tree map.
Recording in progress.
Method. On this method. You observe directly they given map.entry type. Here it is file name appears. That's what dollar symbol, but you can write map.entry. Write this one. It returns map.entry reference. Sorry, set ref. It converts. It converts two-dimensional collection or it converts tree map into a set. So already you studied generic. In a generic you studied, no? This purpose only I taught that program. In array list employee, in employee integer. At the time one program I given TUV. That is given, no? That type. Collection generic in a generic. See here it is generic, again map.entry type. Is it over? See, set generic type. In that generic, it is allowed map.entry only. Key, whichever you want, you can. Value, whichever you want, you can. But it is map.entry fixed. Okay. Otherwise, they can give here also one type like this, no? Okay. That is fixed. Now, that method we have to call. How to call? You give me answer, I'll write. Return type is what we have to write? Set map.entry integer float S equal to tree map dot entry set. Okay. You observe entry set method in which class? That's what tree map reference dot entry set. Okay. Next. Here, what is the return type? Set. What it takes? Map dot entry. K comma B. Here already we written K comma B. That is we have to write. Okay. So like this we have to write. Now iterator I. Iterator again what we have to write? Map dot entry integer float I equal to S dot iterator. This method available in every collection. Okay. Now, because iterator used to iterate elements of any collection. Now, S dot iterator comes. Iterator reference. Outright. What we have to write? While I as next. Next, what we have to write? You already have seen iterator program. Seeing that give answer at least. But return type also required. Map dot entry type. Here integer type. But this is which type? Map dot entry. Again. Here again integer float. ME equal to. How to call? I dot next. Okay. Again. Key separate, value separate. How to call? Integer x equal to me dot get key. Next, float y equal to me dot get value. Okay. Now system dot out dot println x. After printing x, I want to give some arrow, something I want to print like a key value pair. Something, whatever you want, you can write. Space also you can write. Plus y. But I want to add 500 bonus. Plus 500. See this much process. Okay. Two-dimensional collection, we have to do like this. Now, file, save. Compilation, execution. See, here 5,000 salary, 5,500 bonus, 6,500, 7, 6,300, 6,800, 5,500, 6. I don't know. This is iterating. So once again, see, once again, listen. This is already you studied. Okay. Here, whenever you call tree map dot entry set, it is converted into one-dimensional collection, that is set. But in that set, this 101 equal to 5,000 we cannot maintain. Integer format, float format, string format possible, but you cannot add bonus. 500 bonus adding not possible. That is the reason map dot entry prefers. We will prefer. Then integer as it is, float as it is. Okay. Again, what I did, iterator method I called. In previous program, integers iterated. Now what is iterated? Map dot entry iterated. That's what integer plus map dot entry. From this, again I separated key separate, value separate. Key printed, value plus 500 printed. Right, this one. program to demonstrate map.entry. In 2-3 days, collections will finish. After that, multi-threading will start. Multi-threading and synchronization. After that, new features. Still 2 weeks required. 2 weeks. So in this line, two-dimensional collection converted into one-dimensional collection. Here, iterator, same concept I applied. Here, little bit confusion is there, that's it. Only integer was there previously. Here, map.entry is there. In that, again, generic type is there. So here one element iterated. From that extracted, key separate, value separate, plus 500 bonus added. That's it. Two-dimensional collection converted into one-dimensional, then applied iterator. Then what you do is, already iterator program I given, that program, this program, compare, you will understand. There only integer was there, here map.entry was there. This is equivalent to integer in previous program. Is it completed? We'll see continuation tomorrow. Output same, just a 500 bonus. That's it. We'll see continuation tomorrow.